Hi, geometry students. Today we're going to precisely define a point, line, and plane. So up here at our learning target, let's write that down. I can. It's what we hope to do at the end of the lesson. I can precisely define a point, line, and plane. You'll also need to fill in the name. This is geometry and the date. Our essential question is, what does every object on Earth have in common? All right, well, let's find out. Down here we have room for a picture, a definition, and notation. Notation is just a math word for symbol. All right, I'm going to make a mark. And the mark that I made is called a point. So a point names a location. So it's kind of like X marks the spot, but here is a location, and I'm going to name that P. So a point names a location and has no sides. It's just naming a location, but that's kind of confusing, so I'm going to put a squiggle line underneath it. The symbol for a point is just a capital letter P. This is read point P, and it's always a capital. Our next word is when we have not one point, but 2 points. And there's something interesting that we can do with these 2 points, is we can connect them with a line. Okay. And knowing our previous definition is that points need to be named, let's name our points on our line. So a line is an infinite number of points. Infinite just means no limit. It means that there is so many other points besides A and B on this line. So it's an infinite number of points on a straight path that extends in 2 opposite directions. This is important. This is why we have the arrows on the end, because it's part of the definition. With no end and no thickness. We're just going to pause that idea for a second. The last picture I'm going to draw has not 1 point, 2 points. I'm going to make 3 points that are not together on a line. And when we have 3 points not together on the line, they represent a flat surface. And we call this flat surface a plane. So a plane is made up of 3 points not together on a line, and I need to name those. Point X, point Y, and point Z. And there's so many points, more than 1 million, and the lines that can connect to those points that make up a flat surface and extends without end and has no thickness. All right, well, let's go back and name our line. So we have a line going through 2 points, point A and point B. And what we do is we put the capital letter A and B and we draw a picture of the line on top. This is red line AB. A plane, the symbol doesn't make the notation. What we do is we write the word plane, and then we list 3 of the letters in any order, and any 3 points will do. So I could say Y, X, Z. There's one more way to name a plane and a line, and that is if you see in a plane a curvy or italicized capital letter. Notice how the capital letter M has no point. So that's a name. So we can call this plane M. If you see on a line a cursive lowercase letter, that's also a name. You can call this line L. In geometry, we start with definitions. Always start with definitions. And from there we look at patterns that always happen to be. But first, let's talk about those confusing squiggle lines where something has no end, no thickness, and what that is just, it's an idea. So a point, line, and plane are considered undefined terms. Which means that they cannot be defined. So it's undefined. It cannot be defined using other figures. It's an idea. And since these ideas are so basic, we call them axioms. I'll write that over here. An axiom is, it's accepted as a fact. Same with postulates and theorems. And we're going to call all axioms, postulates, and theorems rules, because a theorem is just a postulate that hasn't been proven to you yet. So here are our first rules in geometry that uses our first vocabulary words. So rule number 1, through any 2 points, there is exactly 1 line. So through any 2 points, I can draw a line. Yep, basic, but always gonna happen. Rule number 2, through any 3 non-collinear points. Let's break that word down. So non means not, co means together, and linear, I spy the word line in there. So not together on a line. So through any 3 points that are not together on a line, there is exactly 1 plane containing them. And we see here in our notes, in the definition, we have 3 points that are not together on a line and are contained by a plane. Rule number 3, if 2 points lie in a plane, then the line that containing these points or can be drawn from those points also lies on the plane. That makes sense. Okay. Oops. All right, our learning target, I can define a point, line, and plane. Example number 1, naming points, lines, and planes. So we want to name 5 points. There's a vocabulary word, look it up if you need to at any time. But remember that a point is represented by a location in space. So we're going to have points A, B, D, and E. There's also a capital letter C, and because it is in the intersection or where two lines meet, there is an implied point there. Letter F is cursive. It's a cursive capital letter F, and there's no point. So that is a name. Capital letter F is the name of a plane, as well as capital letter N. There's no point. That's a name. So I'm going to name, let's see, 1, 2, 3, 4, 5. So points A, point B, point C, point D, and point E. Right. The next question, name two lines. There is a horizontal line, and I can name that as line BC, line BD. Many options, just pick one. And there's a vertical line here, line AC. So I need to put A and C in capital letters with a line symbol on top. And that symbol matches the shape of the line. So that makes sense. All right, name two planes. So plane is a flat surface. So this one's kind of tricky to see. I'm going to start with this one this plane that's almost horizontal. And I can name that plane F. Capital letter F has no point. And I could also say plane N, but for variety, and you don't have to, I'm going to use 3 points on plane N. So I can use B, A, and C. Notice that I can't use point E. Point E is not contained within plane N. So plane BAC or CBA. Name a point on line BD. So let's look for line BD. I see it's there in green. And point B is on there, point C, and point D. So I can use any one of the points. And notice that I'm using a point that's right there in the name. If you think of the definition, a line is made up of 2 points, so I can use line B or line D. Right, let's look at some more definitions, 2 more. There's more that I can do with 2 points. We talked about how a line connects through 2 points, but I can just connect these 2 points and make a segment. A segment with a T at the end, or a line segment, consists of 2 points called endpoints. Here's a hidden vocabulary word. So endpoints are there on each end. And all the points in between. Remember that a line has an infinite number of points. It means that there's many, many, many points. And points need to be named. So let's name these points. So we have segment. We start at point A and we end at point C. I'm going to write that a little neater. So we're starting at A, ending at C, and we're making just a line on top of AC. We're not making arrows because we're not extending beyond A and beyond C. There's one more drawing that we can make. We can make a figure that starts at an endpoint and goes through another point. So if we name those, I'm starting at D and going through F, and we call that a ray. It's part of a line, starts at an endpoint, and extends forever in one direction. We would name that with the point that we start with and the point that we go through. And the drawing that we put on top has no arrow at the start point, but an arrow on the point that we go through. Let's practice. Example 2, naming segments and rays. Name 2 segments. Okay, so a segment doesn't go through a point, so I could say segment RS, segment ST, or TS, or I could say segment RT. Notice that there's 3 segments that I can name. And it doesn't matter, just pick, we just need 2. And let's see, I'm going to start at T, end at R. There we go. Name 3 rays. Okay, so a ray, remember, starts at an endpoint and goes through another point. So I have ray SR, ray ST, ray TR, and ray RT. Looks like I have 4 rays that I can name, and we just need to pick 3. Now careful that if I'm going to name ray SR, I need to start at S, end at R, and my symbol needs to show that as well. S does not have an arrow on the top. Use SR, ST, and how about TR? Starting at T, going through R. The next problem, draw and name a ray. We've got a starting point going through another point with endpoints M and O. Oops. Sorry. So I need 2 points, M and O, and M is an endpoint, and I'm going through O. M is an endpoint and passes through O. Okay, here's another example, naming points and lines in a plane. So example 3A, name a line that contains A and C. Let's find A, oops, and C. There's A, there's C. Remember, C is intersecting 2 lines. And so I could say line AC, line AB, line BA, just pick one. But you know what? Look at this. If I know point A and point C have a line that contains them, I can just use A and C with a line above, and that checks from our figure. 3B, name a plane. So a plane is a flat surface that contains A, D, and C. So let's see, it contains A, D, and C. They're not together on a line. And so here's our flat surface. There's our plane. So I can say plane, well, A, D, and C. Notice that I can also say plane M, because there's also a name there. All right. This is a long lesson because there's a lot of vocabulary to start with. Let's use our vocabulary that we just learned and see what kind of rules that would always work. Rules or patterns. So rule number 4 is the figure on the left, and rule number 5 is the figure on the right. Oh, let's not forget our learning target. What is it that we're looking to be able to do after our lesson? Is I can precisely define a point, line, and plane. All right, let's look at these rules. So rule number 4 if two lines intersect, then they intersect at exactly 1 point. So here we have line AE and line DB, and they're intersecting at point C. So we can say that line AE and, need the arrows, line DB intersect. Another word for intersect is that they meet. We can say that they intersect or meet at point C. I'm going to highlight that. That is very important. Okay. Rule number 5, and our last rule, is if two planes intersect, remember planes are two flat surfaces, then they intersect at exactly one line. Okay. So let's find our two flat surfaces. You can think of them like walls intersecting or roads intersecting. Roads would be like rule number 4, walls would be like rule number 5. So let's see, rule number 5, if two planes intersect, so here we have plane STW and plane STR. Intersect at, let's see where they intersect or meet. Well, they intersect at exactly one line, so they intersect at ST. Now you might be saying, Miss Anderson, that's a segment. But with this particular rule, we can imagine that this segment extends forever to infinity. So the rule is that it is intersecting at line ST. Those are our last two rules, and only 2 more practice problems. Let's do it. All right, name the intersections. So the figure on the right is a cube. We see that it has a top and a bottom, a front and a back, which I'm highlighting now, a front and a back. We have a top and a bottom, and we have a left and a right. So we have 6 sides to this figure. It is a 3-dimensional figure. All right, so we need to name the intersection of line CD. So I need to find C and D. And notice that on the box it's a segment, but remember we can extend it to forever. And line DE. There's D, there's E. Oh, and there they do remind us that there is a line. So where do they meet? They meet at point D. And notice that D is in both of the lines. Sometimes that works, but sometimes it doesn't. The rule didn't have, we have A and E and D and B. There's no points in common except for the intersection. All right, for B, name the intersection of plane. So remember, plane is a flat surface. GBC, so that's the top. And plane ABC. That's the front. All right, so we need to find the intersection. It means where they meet of these two, and they meet at BC. Remember, we're going to extend it to forever because that's the rule. So it's line BC. If you put segment BC, it would be incorrect because we need to remember the rule. All right, that's our lesson for today. We'll see you next time.